In this video we're going to talk about rotations. Rotations are another transformation that we can do to points. Again, transformations are ways that we can change locations of a point. So we got a lot of different ones. This specific one is called a rotation. You're going to see rotations most likely in this form. So rotate 90 degrees clockwise, and this is our symbol for clockwise, CW. You're going to see rotate 90 degrees counterclockwise, and you're going to see rotate 180 degrees, and we don't have to say clockwise or counterclockwise because 180 degrees, it doesn't matter which direction we get, we're going to end up at the same spot regardless of whether we go clockwise or counterclockwise. So three different methods that we're going to use today, three different little tricks that I'm going to talk about. The first one, clockwise, means that here's our trick here. I'm going to write it as a coordinate pair. What we're going to do is we're going to flip the x and the y. So the y is now going to be where the x is supposed to be, and the x is now on the y. Although we're not changing their locations. This is still talking about things on the x-axis, and this location is still talking about things on the y-axis, so don't get confused, hopefully. And then what we do is we make y, or the new y, so the x value, the opposite. Alright, so what we do is we flip x and y, and then the new y is the opposite. Alright, so let's do an example here. Let's talk about a specific point. We're going to talk about 3, 6. So 3, 6 is right here. We're going to call that point A. And we're going to perform a 90-degree clockwise rotation, okay? So this is talking about 90 degrees clockwise. Alright, so we're going to swap these values. So our A rotated is going to be, so far, 6, 3, but then we got to make sure our new Y value, so now 3, is an opposite. So what's the opposite of positive 3? It's negative 3. So it's 6, negative 3 right there, that is our A reflected. Okay, so let's get rid of this, let's keep our rules, and let's actually use a shape, because rotations are definitely better viewed as objects. Alright, so let's make a full shape here. Let's say that point R is at 1, 3. And point V is at 3, 5, and point H, let's make it at 5, 4. So at 1, 3, 1, 3, there we go. That's point R. At 3, 5, that's point V, and at 5, 4 is point H. And we got some points here. Let's make a shape out of them, so we can talk about this triangle. Alright, so now what I'm going to do is I'm going to switch colors and talk about the rotated values. So if we remember our rules that we flip x and y, and the new y is the opposite. So let's do that to R here. So R rotated, we're going to switch the x and y values, so now it's 3, 1, and we're going to make the new y value the opposite. So instead of positive 1, it's negative 1. So 3, negative 1 is R rotated. Let's do the same thing to V. Instead of 3, 5, we're going to flip the x and y, so it's going to be 5, 3. And the new y is going to be the opposite. So instead of positive 3, negative 3. So 5, negative 3 is v rotated. V rotated, there we go. And h rotated, instead of 5, 4, we flip them, so it's 4, 5. And the new y now becomes the opposite, so instead of positive 5, it's negative 5. So 4, negative 5 is right there. And that is h rotated. And we can connect them. And hopefully that makes it clear that our triangle got rotated 90 degrees clockwise. So if you think about spinning this 90 degrees, the R now instead of being on the left, it's on the top. We're just spinning it clockwise 90 degrees. The V instead of being on top is on the right, and the H instead of being on the right is now at the bottom. So we spun this triangle around right there. You can also think about a couple of things with our transformations. Think about if the areas change, think about if the slopes of the segments change, and think about if these angles are changing. And so as far as rotations go, the angles definitely didn't change. The size of our triangle did not change. But the slopes kind of did, right? This is a positive slope. Now RV is a negative slope. VH was a negative slope, and now it's a positive slope. And RH was slightly positive, and now it's very negative. So slopes definitely change in reflections. Or I'm sorry, rotations, right? We're rotating right here. They do get confusing. So hopefully you can remember that rotations are turning something. And reflections are just like mirror images. Alright, let's try something else. Let's try counterclockwise. Get rid of this. Let's try 90 degrees counterclockwise and see what we do here. Our rule is going to be the X and Y flip. But if we're going counterclockwise, now X is going to be the opposite. Alright. So if we think about this, I'll rewrite it here. If we start with an X and a Y, we flip them, so it becomes YX, and then we take that new Y, or that new X, I guess, sorry, and we make it the opposite. So these are how they relate, right? Take this, flip it to the front, make it the opposite. If it's positive, make it negative. If it's negative, make it positive. So let's try a shape again. And this time we're going 90 degrees counterclockwise. Let's start with K. We'll make it negative 2, 2. H is going to be at 3, 4. And let's do C at 3, negative 1. So negative 2, 2 is right here. 3, 4 is right there, that's H. And 3, negative 1, that's C. And let's just make it a shape so we can see how it rotates. Alright. So again, we're going to flip the X and the Y value. So K rotated is going to be 2, negative 2. But now X is going to be the opposite, the new X. So instead of positive 2, it's negative 2. So negative 2, negative 2 is going to be our new K, or K rotated, 90 degrees counterclockwise. So we're going to the left and down a quadrant. Here's H rotated. So we're going to flip the values. So it's now 4, 3 instead of 3, 4. And the new X value is the opposite. So instead of positive 4, it's negative 4. So negative 4, 3 is H rotated. And C, again, flip the values. So C rotate is going to be -1, 3, but then make X the opposite. So instead of -1, it becomes +1. So +1, 3 is the new C, the rotated C. Let's connect our points and see how we rotated that shape. So we took this triangle and we turned it left 90 degrees, right? Counterclockwise 90 degrees. So the H is now on the left, the K is on the bottom, and C went to the top. Or the right side, I guess. Alright, one more. Let's talk about rotations 180 degrees. Rotate 180. Alright, so let's try S at -3, 4, J at 1, 1, and W at -3, -3. So -3, 4 is S, 1, 1 is J, and -3, -3 is W. Connect our points, and let's rotate 180 degrees. So the rule for rotation is slightly different. The rule for rotation is to make X the opposite and Y the opposite. So you don't have to flip anymore. You don't have to flip X and Y, you just make X and Y the opposite of what they are. So S rotated 180 degrees is the opposite of -3, so +3, and the opposite of +4, which is -4. So 3, -4 is our new S, or S rotated. J rotated is going to be the opposite of +1 and the opposite of +1. So -1, -1. Right there, that's J rotated. Last one, W, is the opposite of -3, so +3, and +3 again. So 3, 3 is W rotated. Connect our points, and hopefully you see that shape rotated 180 degrees, so it's flipped all the way upside down basically. So the S went from the top to the bottom, W went from left bottom to top right, and J went from the right to the left. Alright. So those are rotations. They're probably the trickiest ones of the transformations, only because the rules are slightly tricky. And there's 3 of them that you gotta know. So yeah. Alright, good luck.